From the first experimental tanks of World War I to the mass-produced machines of global war, American armored vehicles evolved rapidly. This video follows that evolution, from early light tanks to designs that defined U.S. armored warfare. The light tank M1917 was the first tank adopted by the United States Army, entering production in 1917. It was developed on the basis of the French Renault FT, the most influential tank design of World War I. Although intended for combat in Europe, most vehicles were completed too late to see action in the First World War. The design featured a classic layout with a rotating turret, a rear-mounted engine, and a two-man crew. With a combat weight of around 7 tons, it was armed either with a 37mm gun or a .30 caliber machine gun. Armor thickness reached up to 16 millimeters, providing protection against small arms fire and shell fragments. Powered by a gasoline engine producing about 42 horsepower, it had a maximum speed of approximately 8 kilometers per hour. Despite its limited combat use, this vehicle laid the foundation for the future development of American armored forces. The M2 light tank entered service in 1935 as one of the first domestically designed American tanks of the interwar period. It reflected the U.S. Army's early attempts to develop its own armored vehicles rather than relying on foreign designs. Compared to earlier tanks, the design emphasized mobility and mechanical reliability. It featured a light hull and a 4-man crew consisting of a commander, driver, assistant driver, and gunner. With a combat weight of approximately 11 tons, the tank was armed mainly with multiple machine guns, lacking a dedicated cannon in its early versions. Armor protection reached up to 25 millimeters, offering limited protection against small arms fire and shell fragments. Powered by a gasoline engine producing around 250 horsepower, it could reach speeds of up to 58 kilometers per hour. Although the M2 light tank never saw combat, it played an important role in training crews and influencing later American tank designs. The M2 medium tank entered service in 1939 as the first American medium tank produced in significant numbers. It marked a shift in U.S. armored doctrine, moving away from purely light tanks toward vehicles with greater firepower and protection. Compared to earlier designs, it featured a larger hull, a higher silhouette, and a 5-man crew consisting of a commander, gunner, loader, driver, and assistant driver. The tank emphasized crew coordination and battlefield visibility rather than heavy armor. With a combat weight of around 18 tons, it was armed with a 37mm gun and multiple machine guns. Armor thickness reached up to 32 millimeters, providing limited protection by the standards of the late 1930s. Powered by a gasoline engine producing approximately 350 horsepower, it had a maximum road speed of about 42 kilometers per hour. Although it never saw combat, the M2 medium tank served as a crucial stepping stone, directly influencing the development of later American tanks such as the M3 Lee and M4 Sherman. The M3 Stuart entered service in 1941 as the main American light tank of the early Second World War. It was designed for reconnaissance, screening, and infantry support, emphasizing speed and reliability. Compared to earlier U.S. light tanks, it featured improved armor layout, better mechanical reliability, and a more capable suspension. The tank had a 4-man crew consisting of a commander, gunner, driver, and assistant driver. With a combat weight of approximately 14 tons, it was armed with a 37mm gun and several machine guns. Armor thickness reached up to 38 millimeters, offering protection against small arms and light anti-tank weapons. Powered by a gasoline engine producing around 250 horsepower, it could reach speeds of up to 58 kilometers per hour. The M3 Stuart saw extensive combat service in North Africa, the Pacific, and Europe, becoming one of the most widely used American light tanks of the war. The M3 Lee and Grant entered service in 1941 as an emergency medium tank for the U.S. Army and its allies. It was designed to provide increased firepower while a fully turreted medium tank was still under development. Compared to earlier American tanks, the design emphasized firepower over layout efficiency. The tank had a crew of 7, allowing effective operation of its complex weapon system. With a combat weight of around 27 tons, it was equipped with a 2-level armament layout. A 75mm gun was mounted in a sponson on the hull, while a 37mm gun was placed in a rotating turret above. Armor thickness reached up to 51 millimeters, offering improved protection compared to previous U.S. designs. Powered by a gasoline engine producing approximately 340 horsepower, it had a maximum speed of about 40 kilometers per hour. The M3 saw significant combat service in North Africa and played a crucial role during the early stages of the war, serving as a direct predecessor to the M4 Sherman. The M4 Sherman entered service in 1942 as the primary American medium tank of the Second World War. It was designed for mass production, battlefield reliability, and ease of maintenance across multiple theaters of war. Compared to earlier U.S. medium tanks, it featured a fully rotating turret with a 75mm gun, improved internal layout, and better overall balance between firepower, mobility, and protection. The tank had a 5-man crew consisting of a commander, gunner, loader, driver, and assistant driver. With a combat weight of approximately 30 tons, it was armed primarily with a 75mm gun, later upgraded to more powerful variants. Armor thickness reached up to 75mm, providing adequate protection by early and mid-war standards. Powered by a gasoline engine producing around 400 horsepower, it could reach speeds of up to 48 kilometers per hour. The M4 Sherman saw extensive combat service on all major fronts and became the most widely produced American tank of the war, forming the backbone of U.S. and Allied armored forces. The M26 Pershing entered service in 1945 as the most powerful American tank of the Second World War. It was developed in response to the increasing armor and firepower of late-war German tanks. Compared to the M4 Sherman, it featured significantly improved armor protection and a much more powerful main gun. The tank had a 5-man crew consisting of a commander, gunner, loader, driver, and assistant driver. With a combat weight of approximately 41 tons, it was armed with a 90mm gun capable of engaging heavily armored targets. Armor thickness reached up to 102mm, providing a high level of protection for its time. Powered by a gasoline engine producing around 500 horsepower, it could reach speeds of up to 40 kilometers per hour. Although it entered combat late in the war, the M26 Pershing marked a transition toward post-war American main battle tank designs. In the years that followed, this evolution would continue through a new generation of tanks, leading to the development of the Patton series and shaping U.S. armored forces throughout the Cold War. The M46 Patton entered service in 1949 as a direct development of the M26 Pershing, addressing its main shortcomings. It was introduced to improve mobility, reliability, and overall combat effectiveness in the early Cold War period. Compared to its predecessor, the design featured a more powerful engine, an improved transmission, and enhanced automotive performance. The tank had a 5-man crew consisting of a commander, gunner, loader, driver, and assistant driver. With a combat weight of approximately 44 tons, it was armed with a 90mm gun capable of engaging contemporary armored threats. Armor thickness reached up to 102mm, maintaining protection levels similar to the Pershing. Powered by a gasoline engine producing around 810 horsepower, it could reach speeds of up to 48 kilometers per hour. The M46 Patton saw combat service during the Korean War and marked the beginning of a new generation of American post-war tanks. The M47 Patton entered service in 1951 as an interim solution during the early Cold War period. It was developed to rapidly replace older tanks while a fully new design was still under development. Compared to the M46, it featured a completely new turret, improved fire control systems, and better crew ergonomics. The tank had a 5-man crew consisting of a commander, gunner, loader, driver, and assistant driver. With a combat weight of approximately 46 tons, it was armed with a 90mm gun supported by multiple machine guns. Armor thickness reached up to 110mm, offering improved protection compared to earlier Patton models. Powered by a gasoline engine producing around 810 horsepower, it could reach speeds of up to 48 kilometers per hour. Although it saw limited combat use, the M47 was widely deployed with U.S. allies and played an important role in standardizing NATO armored forces. The M48 Patton entered service in 1952 as a major step forward in American armored vehicle design. It was the first U.S. tank developed from the outset with the concept of the main battle tank in mind. Compared to earlier Patton models, it featured a new hemispherical turret, improved hull design, and better overall protection. The tank had a 5-man crew consisting of a commander, gunner, loader, driver, and assistant driver. With a combat weight of approximately 49 tons, it was armed with a 90mm gun capable of engaging both armored and fortified targets. Armor thickness reached up to 120mm, providing significantly improved survivability. Powered by a gasoline engine producing around 810 horsepower, it could reach speeds of up to 48 kilometers per hour. The M48 saw widespread service throughout the Cold War and became one of the most widely used Western tanks of its era. The M60 entered service in 1960 as a direct evolution of the M48 Patton, reflecting lessons learned during the early Cold War. It was developed to counter increasingly well-armored threats through improved firepower and long-range engagement capability. Compared to the M46, M48, it featured a new main gun, an improved fire control system, and refinements to the hull and turret design. The tank retained a 5-man crew consisting of a commander, gunner, loader, driver, and assistant driver. With a combat weight of approximately 52 tons, it was armed with a 105mm gun, giving it a significant increase in anti-armor capability. Armor thickness reached up to 120mm, offering protection suited to Cold War battlefield conditions. Powered by a diesel engine producing around 750 horsepower, it could reach speeds of up to 48 kilometers per hour. The M60 became the primary American tank of the Cold War era and was widely used by U.S. forces and allied nations for decades. The M1 Abrams entered service in 1980 as a new generation of American main battle tanks, designed to meet the demands of modern high-intensity warfare. It marked a major technological leap compared to Cold War era designs. Compared to the M60, it featured advanced composite armor, a digital fire control system, and significantly improved crew survivability. The tank had a 4-man crew consisting of a commander, gunner, loader, and driver. With a combat weight of approximately 60 tons, it was initially armed with a 105mm gun, later upgraded to a more powerful 120mm smoothbore cannon. Armor protection relied on composite materials rather than raw thickness, offering superior resistance against modern anti-tank weapons. Powered by a gas turbine engine producing around 1,500 horsepower, it could reach speeds of up to 67 kilometers per hour. The M1 Abrams saw extensive combat service from the late Cold War through modern conflicts and remains the backbone of U.S. armored forces today. The M1A1 Abrams entered service in 1985 as a major upgrade of the original M1, significantly increasing its combat effectiveness. It was developed to counter heavily armored threats and reflect lessons learned from modern armored warfare. Compared to the early M1, it featured a more powerful main gun, improved armor protection, and enhanced survivability. The tank retained a 4-man crew consisting of a commander, gunner, loader, and driver. With a combat weight of approximately 62 tons, it was armed with a 120mm smoothbore gun, giving it a decisive increase in firepower. Armor protection was further enhanced through improved composite armor technology. Powered by a gas turbine engine producing around 1,500 horsepower, it could reach speeds of up to 67 kilometers per hour. The M1A1 saw extensive combat service during the Gulf War, where it demonstrated overwhelming superiority against older armored vehicles. The M1A2 Abrams entered service in the early 1990s as the most advanced variant of the Abrams family. It was developed to integrate digital technologies and improve battlefield awareness in modern combined arms warfare. Compared to the M1A1, it featured advanced fire control systems, digital command and information networks, and improved target acquisition. The tank retained a 4-man crew consisting of a commander, gunner, loader, and driver. With a combat weight of approximately 63 tons, it remained armed with a 120mm smoothbore gun capable of engaging modern armored threats at long range. Armor protection was further enhanced with upgraded composite armor and improved defensive systems. Powered by a gas turbine engine producing around 1,500 horsepower, it could reach speeds of up to 67 kilometers per hour. The M1A2 Abrams represents the peak of American tank development and continues to serve as the core of U.S. armored forces in the 21st century. From the first experimental tanks of World War I to the modern main battle tanks of today, this video traced the evolution of American armored vehicles. Each design reflected the challenges of its era, showing how technology, doctrine, and battlefield experience shaped the development of U.S. tanks. If you found this overview informative, consider supporting the channel. Like the video, subscribe, and share it for more documentary content on military history and armored vehicle evolution.